Hello everybody, this is Wolfgang Gensch from the UberCloud, and I would like to present today about UberCloud's journey to use SUSE Linux BCI, the Base Container Image, as a building block for high-performance computing containers. And with me and working with us on this endeavor is Daniel Gruber, our Director of Architecture, then Marco Varlese, SUSE's distinguished engineer, and last but not least, Fedijan Koskuner, our manager of operations at UberCloud. Jumping right to the agenda, high performance computing, that's where we start with, HPC in the cloud, because I guess not everybody in the audience is really fully informed about what high performance computing in this context means. Next then is HPC containers and engineering simulation platform, which UberCloud worked on for about 6-7 years now. And everybody, I think, knows about the CentOS dilemma, end of life last year, etc. And SUSE Linux, number 4, an excellent alternative for high-performance computing. Number 5, SUSE Linux Enterprise Base Container Image, BCI. So here Marco jumps in. And finally, I conclude with SUSE Linux Base Container Image as a building block for high-performance computing containers, which is quite new. Okay, so let's jump right into the first part, high-performance computing in the cloud. And as you know, engineers and scientists, they model everything these days, not only climate, environment, but also oil and gas, personalized healthcare, virology, drug design, turbomachinery, automotive combustions, and many, many more. And all these applications, simulations are highly resource intensive, so compute intensive, and that's why it makes a ton of sense to move them to high performance computing machines, and recently, these days, obviously, into the cloud. So now with everything sitting in the cloud, and here containers come into play, and the engineering simulation platform, which you can move to every cloud infrastructure. So this can be accessed not only by the high-performance computing user in the office, but recently, especially more and more, also from the home office. As you can see here behind me, this is my home office. It has everything, and not only office stuff, as many of you. And even in the plane, you can sit there and access your application simulation container on SUSE Linux in the cloud. Okay, so that was it already. Next is the HPC containers that UberCloud has developed. And basically, we started very early with Docker, but then turned more and more to high-performance computing add-ons. As you can see here in the box on the right-hand side, these are computer-aided engineering software container images, which we have enhanced for engineering and scientific applications. So the applications themselves, they are pre-installed into the container and tested and certified by UberCloud. And they contain all the high-performance computing and computer-aided engineering tools an engineer needs, such as message passing interface, for example, or remote visualization, or access and use of InfiniBand, and so on, and so on. So they can be executed on any public, private, and hybrid cloud, and even multi-cloud recently, with an application which we have done in the Living Heart project activities. As this all is a fully managed service on cloud and on premise and running on CentOS, VMs, bare metal, OpenStack, vSphere, Kubernetes, and more. And it can be coupled with Linux and Windows containers, which can even sit on the client's side. So a little screenshot here, as you can see, so two different screenshots, but one is your desktop and the other is the desktop inside the HPC container in the cloud. Look and feel identical, no learning needed. You basically seamlessly continue to not only move your application and data to the cloud, but especially also do interactive things like pre-processing, post-processing, remote viz, submitting jobs, set up cloud clusters, and so on and so on. Okay, so very quickly, the UberCloud engineering simulation platform. Underneath the containers, you'll see on top you have the containers with different applications and even highly complex multi-physics workflows an engineer has developed for years already and is now working for the next generation of products, for example, for their companies. The middle layer then is management and services that we do often with partners like GNS and Science and Computing. And the lower level, these are the well-known and widely used cloud platforms from, for example, Amazon, Azure, Google, and Oracle. Okay, so now here in this part, I welcome our Director of Architecture, Daniel Gruber, who now jumps in. Daniel, the floor is yours.
Thank you, Wolfgang. UberCloud's next generation HPC engineering platform is based on Kubernetes. It provides a very simple to use self-service user interface for an HPC engineer. Within this user interface, the HPC engineer can pick its favorite application like ANSYS, COMSOL, or Abacus. Then it deploys a fully configured Kubernetes cluster running a cloud-based desktop, GPU accelerated, where the engineer interactively can work with. If the engineer requires more compute nodes in his private dedicated compute cluster, he can just resize this cluster interactively. Other integration points are a container or a command line utility, which can be integrated in any existing workflow like a CI/CD pipeline or an existing HPC workload manager for scale-out computing. For D2 operations, all clusters can be integrated in Ranger so that you have additional possibilities to do a multi-cloud, to provide a multi-cloud environment. But also traditional user portals like Azure or Google Console can be used for maintaining the Kubernetes clusters. With that, back to Wolfgang. Thank you.
Okay, so after Daniel now nicely explained this next generation high performance computing engineering platform that Daniel has not only architected, designed, developed, so really implemented and worked with real examples. I mentioned before, for example, a large living hall project on Google Cloud for computing and on Azure then with all the management orchestration tool sets, especially with SUSE Ranger. Okay, so yeah, back to the CentOS dilemma, which I mentioned when I explained the agenda. We all know that CentOS has been end-of-lifed last year, and our containers were all implemented on CentOS. Until then, yeah, fortunately, was very good OS, but we were thinking of what to do, and we decided to get into a strategic partnership with SUSE and work together on moving all our stuff basically to SUSE Linux. And that started beginning of 2021 already. Basically when end of life of CentOS has been announced. And we immediately did like 6-7 projects, as far as I remember, with SUSE Linux, with Liberty Linux, with Slash, RKE, so the Kubernetes managed platform. And last but not least, recently we moved our high performance computing UberCloud containers then to SUSE Base Container Image. And that was our largest project, so to speak. So we already had a keynote about the next steps, or the future, at SUSECon 2021 in an Azure HPC keynote together with great people from Azure, a cloud built for HPC plus AI. You still can access it. I have a link at the end of this presentation. And then we worked on a case study together with a customer, 3DT Holdings, preparing, as they call it, revolutionize heart valve surgery. And the platform was SUSE Ranger and UberCloud containers and the engineering simulation platform. There was a press release in April 2022. So UberCloud is now a SUSE Gold partner because of all the activities that we worked on together. And now here at SUSECon 22, we have two presentations, this one, and then from Daniel Gruber about multi-cloud high-performance engineering simulations with SUSE Ranger. So the last part, a glimpse into SUSE Linux Enterprise Base Container Image. So this is Marco, who will present this, the distinguished engineer at SUSE. Marco, please, it's your turn.
Thank you, Wolfgang, for the nice introduction and the topic that you covered so far. What I would like to discuss now and present to you is the SUSE Linux Enterprise Base Container Images and the concept and vision behind that, just to give everybody an understanding and a better view on what these are. So my name is Marco Varlese and I'm a Director of Engineering here at SUSE. And without further ado, let's get started. So what's the vision behind SLE BCI, or the Base Container Images? Well, we wanted to basically create a flexible developer experience that provides and integrates and supports languages natively like Python, Ruby, Perl, Java, and so on. Not just the languages themselves, but also the tools and the workflows by offering a self-contained environment targeting any specific version of these programming languages. So you could imagine OpenJDK 17, OpenJDK 11, or Python 3.9 versus Python 3.6. All of these programming stacks self-contained in a single container image with the idea to basically facilitate software development, testing, and deployment, starting from day zero up to when the container image finally lands in a production environment. Our short-term demands and deliverables was to basically provide a set of images with recommended security hardening applied and pre-configured access to a developer-focused repository, which has to be freely available for everybody. What this basically means is with SLE BCI, you have full access to packages which are enterprise grade packages shipped already with SLES, but they are given to you for free using SLE BCI. Obviously, the set of repository is not the fully fledged SLES repository, and we will talk through this in a little bit. Finally, the container image must be freely distributable. And as I said already, the repository available without a subscription. The freely redistributable idea comes because obviously application developers or ISVs in general will have to redistribute the container image with the artifacts, with the content that they add to these images. And so it is very much foreseeable that a redistribution right is in place for these container images. And in fact, there is. Where are we today? We have, as I said, a SLE BCI repository, which is available by default on all BCI images, and it contains today more than 4,000 packages. Sure, this is much smaller repository than what you can get with a SLES subscription, but these packages so far have demonstrated to be perfectly suited for all kind of software development purposes. We also have a permissive EULA, which basically enables the redistribution of images derived from our SLE BCI image. So you can imagine the scenario where you use in the from clause any of our SLE BCI images. Well, then our EULA today enables you to redistribute your derived image wherever you like. That said, if you already own a SLE credential, so you have a subscription, then you can push those credentials into this SLE BCI image, which then enables the full SLES repositories on the image itself. It has to be said that if you run SLE BCI on top of a SLES host, this automatically happens. So there's no need to do the extra steps to push the credentials to the image. When running SLE BCI or building SLE BCI derived image on top of a SLE host which is registered, so with valid credentials, then this step is automatically taken care of. Last but not least, we guarantee FIPS compliance when using SLE BCI images with a paid subscription. However, all SLE BCI images still work perfectly fine on a FIPS enforcing host, even in their free form. However, you cannot basically claim compliance for those. Now, just a short slide here with some pointers. We have a landing page where you can find some basic concept about SLE BCI and other links to, for example, documentation and so on. Our registry, which is the SUSE registry, is registry.suse.com, and that's where you will find all the available SLE BCI images. It's pretty much updated every day. You will find the new tags, all tags of each individual image. You will find also the beta images published there as soon as they become available. And finally, a container guide that you can basically go through and find out more about the details of SLE BCI. With that, I would like to basically pause and pass the talk to Wolfgang again. Thank you very much for listening, and please join our other talks on SLE BCI to learn more about the technical details surrounding this beautiful technology. Thank you and enjoy SUSECon.
Okay, back to our implementation of the HPC containers onto SUSE Base Container Image. So the porting happened in the last 2 months, just with testing, polishing, and certifying, basically. And so just a deeper look into UberClouds high-performance computing container. So there are different sets of features, so basic and administrative. So for those who have a deeper knowledge about high-performance computing, they know that the following features are very important. To scale, you need multi-container. single node, but also multi-container, multi-node. This comes a little bit later under the advanced features. Then SSH between containers, because containers have to communicate because they sit on different servers, on different compute nodes in a cluster. Right? Usually that cluster has InfiniBand interconnect to do a very fast communication, and the container has to know about that. And this has been ported from the HPC container to BCI then. Up-to-date Linux, obviously, Kubernetes and SUSE Ranger, screen sharing for a team, cloud data storage connectors, emailing features, reporting the job status, hey, you're ready, or hey, there is a failure, or whatever, right? License server is sitting in every container because these simulation software, they use usually the commercial ones. They usually licensees, and you want to put this into a license server which can sit in the cloud or on the user's on-premise environment, right? So MPI libraries, message parting interface, NFS, some administrative on the right-hand side, automated password generation. So there is no password coming, for example, from us. And also the user does self-service password change for increased privacy. UberCloud doesn't have its fingers into any of these features into the container. It's all under full sole exclusive control of the end user. Right? Unlike a few other offerings in the market where you go through portals or you're through appliances, working through equipment of the cloud service provider, for example, that the cloud service provider controls. Okay, so this here is full sole exclusive control under the control of our customers, of the engineers, in fact. Advanced, okay, multi-cloud. We do this with Ranger. Recently, we had Ranger sitting in the customers' Azure, Microsoft Azure subscription, but all the clusters, 3,000 clusters, have been spun off on the Google Cloud. Then we have virtual private network and features which allow pay-per-use. Then, as you see here, as I mentioned before, multi-container, multi-node, InfiniBand, nice DCV for remote visualization with high definition, vCollab for data extraction, and quite a few others, which I don't have the time to go into the details. But you will get the slides later on, and then you can dig into that for yourself. Thank you. So additional material. So reach out to UberCloud. Obviously, the Living Heart project case study is here. You click on it. There is a very nice blog on the SUSE blog site about 3DT Holdings and SUSE and UberCloud. Then the other SUSECon article here, multi-cloud high-performance engineering simulation with Ranger from Daniel Gruber that I mentioned. And finally, the old keynote, last year's keynote, together with Microsoft Azure as a sponsor then. Okay, and I think that's it. So I hope it was fun and insightful. And for any other question, please simply contact us, either blah blah blah./help or wolfgang.gensch@ubercloud.com. Thank you very much and have a great day. Bye bye.